Hi, my name is Lucas Granucci from Minnetonka High School. My research is titled Science Across Languages, a modular multi-agent LLM framework for document-level scientific translation in low-resource languages. The problem I am addressing is the current landscape of global academia contains significant linguistic disparity. English has been established as the international language of science since the late 1900s, creating a systemic barrier for non-native researchers, who report disproportionate disadvantages in both time to publication and comprehension. Currently, machine translation is being used to address this problem. Standard neural machine translation, or NMT, relies heavily on large-scale parallel corpora datasets that contain aligned source and target language sentences. For low-resource languages, such data is scarce and even more so in specialized scientific domains. Additionally, these models often operate at the sentence or paragraph level, failing to maintain translation coherence across longer documents. This results in the loss of technical context and inconsistent terminology throughout translation. The objective of this study was to determine if a modular agentic LLM framework could outperform traditional NMT models by treating translation as a multi-step reasoning task rather than a simple sequence-to-sequence task. However, before the proposed model could be implemented and tested, parallel and domain data had to be acquired. This research developed a novel automated corpus creation pipeline that acquires article PDFs in the target low-resource language from open access databases, converts them into text, and applies language filtering before using the state-of-the-art graph translation framework with ChatGPT 4.1 to back-translate them into English. These translations were then treated as parallel data for English to low-resource language translation evaluation. To solve the issue of context loss, the proposed framework models documents via a direct acyclic graph where the nodes are discrete discourse units rather than plain sentences, and the edges represent relationships between discourse units, indicating which units would be beneficial to have at the time of translation. Additionally, inter-discourse memory is also enhanced via pronoun resolution to maintain consistency across documents. Apart from better context management for translation, this method also requires less resources than a fixed window system, as only necessary memory is provided as context. The proposed framework can be seen in its entirety here, with the top half creating the directed graph from the input document using a segmentation agent to partition the text into logical units, and an edge agent to establish the relationships between these units. Next, each discourse unit is processed by a memory agent that retrieves connected units and aggregates the memory of each discourse with its translation in a memory database that persists across translations. Additionally, modular agents are integrated to further provide context, such as a terminology agent that uses a ground truth glossary to aid in translating obscure terms. Finally, the translated discourse units are combined to create the final translated document. This framework uses the 2.57 billion parameter model to processing and the more robust GPT 4.1 for translation. A key feature of this framework is the fact that it's language and model agnostic, meaning as LLMs continue to improve, it's a drag-and-drop replacement to immediately boost performance. For initial tests with the base version of the framework was evaluated in the same translation tasks as Google Translate NMT, Vanilla GPT 4.1, as well as Meta's No Language Left Behind model in two sizes, developed specifically for low-resource language translation. The tested languages were Vietnamese, Turkish, Thai, and Swahili. Comet is the most robust evaluation metric used, as it is a neural network trained to take fluency and precision of translation into account to mimic human evaluation of translation. Blue, CHRF, and TER are less robust but still provide insight into how well translations match ground truth. The results show that this work consistently outperforms the competition in a vast majority of metrics across languages. Quantitatively, the improvements were substantial. When compared to Meta's NLLB models, the proposed framework outperforms them by anywhere from 3.6 to 17%. Against the more robust GPT 4.1 and the industry standard Google Translate, the proposed framework still yields superior results, outperforming them by anywhere from 0.7 to 4.36%. These findings suggest that the modular decomposition of translation tasks effectively mitigates the data scarcity problem in low-resource languages. Future steps will involve seeking out human evaluation from native speakers of the tested languages. While this approach is more computationally expensive than traditional models, the trade-off for accuracy is justified in high-stakes scientific and academic domains. In conclusion, this research provides a scalable solution for democratizing science. By making this technology available in an open access repository, this framework seeks to provide easy, cheaper, and more efficient ways to translate scientific documents to low-resource languages, democratizing access to science around the globe. Thank you.